Hello everyone. Are you able to hear me? Uh, can somebody reply or I'm not audible to you? Can somebody reply? Okay, if you're not, I don't know whether you're able to listen or not. So I'll wait for some time and then let's see. Are you able to hear me or not? Like, why did you join if you're not able to speak out? Okay, thank you. So okay, I'll wait for some time. Like we are only two, three people. So I'll wait for some 5 minutes and then let's see. Yeah. Hello. Hi. So, okay. So have you went through the lectures of 11th week?
Not completely, sir.
Okay. But I guess this Saturday is the this Saturday or Sunday is the deadline, right? For
Yeah,
11th
yes,
week.
yes,
Okay.
sir.
But there is nothing new in this 10th and 11th, 11th week, right? All the concepts, I guess you're already aware of that. You just need to solve some problems, right? And one more thing, was there any problem in the marks that you got in the quiz? Is there any issue? Because somebody are posting on the Discord. Is there anyone here who is having any issue in the marks? Then how come somebody like was posting on the Discord their marks were deducted or what reduced? I don't know. Okay. So what should we do today? Like 11th week, the concepts. Should we discuss the concept because the concepts I guess you already aware of that. If you are having any doubt in those any like videos or lecture, you can ask me. Or if you're having any issue in solving any problems, you can ask me.
Sir, as you planned that today we'll revision that conceptual tomorrow problems, right? That you told that last session, right, sir?
Okay, so I'll just go through the slides, but there's like if you would have
Uh,
seen some of the lectures, you'd have went, you'd have come across the all the concepts that you have already learned, right? Those concepts are already have learned somewhere in stats one and two,
Statistics, yes.
right? So there is nothing new. Whatever there is a new, I'll just go through that. Okay, I'll just share this screen. Let's see. In the recap videos, all the concepts related to discrete random variable has been discussed, right? So, was there any issue? Like, is there any issue in this? Like, you already know what is sample space, event, axiom of the probability stuff. And there's a basic examples given here. Disjoint sets, what is exhaustive sets and all, so exhaustive events. So those are like the sample space has been discussed here. So I don't think so there's any issue in this. So there's no point in discussing this. If you are having a doubt, you can ask. We'll discuss. Otherwise, we'll move forward. Okay. So like these are the recap. Like the 5 6 slides would be the recap of the 11th week. That generally consists of the discrete random variable. Okay. So the professor has just like briefly explained about the what is sample space, what is experiment and all. Event as a set. Okay, and the power set is an I guess new concept, but fine. Like why do we generally represent 0, 1 and to the power omega? It's like whatever the sets are there in the omega or whatever we are having the sets, right? So either like whether we can choose that or we will not choose. That's why we generally this is just a way to represent. There is nothing special about this. It's just a way like different professor has different way to represent. Like different books generally represent the same thing with different uh, what you can say things. Okay, so he just represented the power set in this form. Like 0 1 is just a way. Okay, like I just he took the example of coin tossing experiment, right? So if the coin has been tossed, whether it can come head or tail, right? So in the first, nothing has changed, so phi is there. This is the power set. So whatever this is the f or what. So this is generally taught in uh, modern algebra, I guess, the sigma algebra and all. But he just took the how generally you represent the power set. Like this is a whole set. Like if you're having head and tail, if you have just tossed the coin, and you can get what head or tail. The power set is what then you can get not this is the phi or head or tail or both head or tail. This is just the way to represent something special about this. And he just took the different examples like what is this is I think so dice throwing the dice experiment. This is the double coin toss experiment. Okay. All are the basic examples that you already went through somewhere in stats 1 and 2. So, and this is the basic axiom or the axiom of properties that the summation of all the events should be equals to 1. And each value of the probability event should be greater than equals to 0. And if we are having some n event or n sets, and if those are so can somebody tell me the difference between exhaustive and the sorry mutually exclusive? What is mutually exclusive and whether mutually exclusive mean this is a disjoint set or not? Can someone from you? Okay. So if see you're having n different sets like a1 to an, okay, and if this is a disjoint set means what? There is nothing common between them, so the intersection would be 0. Okay, and if that is an exhaustive set, So if that set is exhaustive and is disjoint also, or you can say the disjoint means mutually exclusive also. So if this is exhaustive and mutually exclusive, then you can write directly this set, this one. The probability of A1 union A2 equals to this one equals to 1, because exhaustive means you are having this many sets only in the particular event. Okay. So there is a basic difference with the, if somebody is asking you regarding a mutually exclusive thing, like there is nothing common. Like if you are tossing a coin, head and tail can't come together. This is simply exhaustive. Sorry, exclusive. And exhaustive means we can get only head and tail, right? So this is the total, what the probability of head plus probability of tail will be equals to 1. Okay. And these are all the basic simple examples of all the probability stuff. There's nothing new in this lecture. Like at least the recap doesn't have any. These are basic, like A in complement will be equals to 1 minus probability of A, and if you need to calculate the A union B, then A plus B minus A of you need to reduce the common part. Okay, and this is just a way to represent B given A. So this is how he represents. Okay, fine. And if you have to calculate A union B union C, then the same thing you need to do A plus B plus C, and then subtract the A intersection B, and similarly for B intersection C, C intersection A, and then because you have done it, like you have already subtracted the very common part, so you need to add the A intersection B intersection C, and this can be used for the n sets also. And how do you calculate the, like this? How do you calculate the probability of some stuff like the favorable outcome upon the total outcome? This is what has been discussed. There is nothing. I guess there won't be any issue in this recap the first lecture. The second lecture generally tells us like is about the conditioning thing. So conditioning, you already know the basic formula of the condition thing, like A condition B is A intersection B upon the probability of B, right? So the conditioning thing is also nothing new for you. You already have studied all this stuff. So this is just a recap of all your probability stuff that we'll be using in next upcoming, what you can say, the courses, and just the brief of everything has been discussed in 1 week itself. Okay, this is total probability law. This is what I was saying. It's the intersection of all the events. Is the total, whatever the events we are having is the exhaustive, and if there is nothing common in between two events is the mutually exclusive, or you can say the disjoint set also. Okay. And if you have to show this, the two events are independent in the product, the intersection A intersection B should be equals to the probability of A multiplied with probability of B. And this should be this, like for example, and this should occur for each and every time. Like if you are having, like if this is a one random variable, if you are dealing with two or three random variables, so you'll be getting some sort of chart and okay. So if you need to show the independent, then you need to, if for even for one condition, if this is not satisfying, this is not a independent. So it should satisfy for all the conditions. Like if you're having 4 cross 4 matrix in the form, like if you're having the random variable, discrete random variable with x as 4 number of domain and y also 4, so you'll be getting 4 cross 4 matrix. Okay. So for each of the elements, it should satisfy the product, the intersection, the intersection of A and B should be equals to the product of probability of A into B. Right? And it should satisfy for all the conditions. Not even for one condition, if this is not satisfying, then this is not an independent event. Okay. These are all basic formulas, basic not formulas, basic example that we have done so many number of times. So those of problem you'll not get the basic problem. You'll get some problem that need a little bit of, what do you say? You can solve the problem with the basic properties that you already know, okay, but not the very basic question you'll be getting here. And again, the third lecture is I just explain what is random variable, how will you define a random variable and all stuff. So till now, any issue? Is there any issue? It was better if you would have told me, like, if you will tell me the topics and all, because all these stuff we all already discussed, and if I'm going through all this again and again, I don't think so this will benefit you also, because all these things you already know, or right? Can somebody say anything?
Yeah, actually, we can go for the additional thing which we have not learned in the stats in the previous.
What are the, like, that is what I was asking. Which sort of things should we discuss? Like, what are the additional things that you have got here?
Yeah, that will be, if you tell me, then it will be better now.
Richard?
What are the topics which are not available in the previous stats course? So that only, if you tell, it will be useful actually, because it's all repeated only now.
Okay, but the one guy is saying just to. Okay, so I'll just go through the whole slide. If you find this as a new, you can just stop me at that point. There are some points like transformation. Those things you have not learned. The convolution theorem that you didn't learn earlier. Okay. Otherwise, I guess you have already learned everything. I guess there won't be any issue, but I'll just go through that. So now the fourth is the expectation and variance. So expectation and simple variance formula, we already have learned how to calculate the expectation if you're having some random variable, and if you have defined some random variable, how to calculate the expectation and how to calculate the variance. So that's pretty simple, right? So this fourth lecture is all about the expectation. How do you calculate the expectation and variance? So you can calculate the basic formula. You need to just, because we are dealing with discrete, so you can just do the summation over all x, and the basic formula is x into the density of the PMF what you are getting for that function. Okay. So and variance also you can calculate. The basic formula is that you need to calculate the expectation of what, x minus ex ka whole square, or simply the formula is you should calculate the expectation of x square and subtracted the mean chi-square. Mean chi-square means the variance, sorry, the expectation, whatever you have calculated, that you need to square it and subtract it from the expectation of x square, you'll get the variance of x. The basic formula. On the Discord, somebody was asking me adding one question, the variance, that variance problem. Okay, so optimum variance. I guess C is the correct answer to that. I'll correct that. And once again, I'm asking you, was there any issue in marking or anything in the quiz 2 marks? Did anyone face any issue? Okay. So now we'll deal with the multiple random variable. Multiple random variable also, like here we'll just discuss about the two random variables has been discussed here. So joint distribution, you already know, the marginal you know, and I guess what is the left, the conditional distribution. So the joint generally you can calculate with conditional multiplied with margin. This is the basic formula that you should be knowing, right? Okay. And the joint distribution of xy is what? The probability such that x equals to x and y equals to y at that point, right? And if you need to calculate the CDF, then CDF generally simply means the probability of capital X would be less than equals to small x, comma like capital Y would be less than equals to small x. If you are having two random variables, you can deal with multiple number of random variable also. This is a basic simple example where x is like is just toss, like this is a basic example of dice throw, yeah, double dice throw, and where x generally x is a random variable that represents the result of the first dice, and y is the difference between the absolute value whatever you are getting. Like you are just throwing the dice twice, and the random variable x represents the whatever the outcome you are getting on the first dice, and the random variable y I have defined as the absolute difference between the number whatever I am getting on the two dice. Okay, and this is how it has been represented in the table form. So here this means what? So here here if I need to know regarding this element of this matrix, okay, 2 upon 36, that means the x equals to 2. That means the first outcome, whatever I'm getting, is 2, and the y means y is 1. That the difference between the difference between what, like I'm showing two dice. So whatever like I got in the x, like in the first die, whatever I got, and whatever I got in the second one, the difference, the mod of the difference between them should be equals to 1. And then we have calculated the probability, we got 2 upon 36. This is what 2 upon 36 generally presents. Okay. And on it will, this is a joint distribution, right? The joint distribution is simply what is the value, the probability value of that particular point. Like if I've defined x equals to some alpha and y equals to some beta, you need to know regarding when x equals to alpha and y equals to beta, what is the probability at that point. That generally will tell you the joint distribution at that point. Okay, because we are dealing with the discrete. If in the marginal conditional marginal, what you need to do, you need to, if you have to calculate the marginal distribution of x, then what do you need to do? You need to just fix the x and do the summation over all the y. Similarly, you can do for the marginal distribution of y also. If you need to calculate the marginal distribution of y, you can just fix the value of y and then do the summation of over all the x. Okay. And if you need to calculate the conditional distribution can be said as the basic formula. Like you need to do, like if you have to calculate the marginal distribution of x given y, then you need to divide it with the marginal distribution of y, and then the upper side will be the joint distribution of xy. And from here you can conclude that the joint distribution simply equals to the conditional distribution and multiplied with the marginal distribution, right? So if you have been asked to calculate the joint distribution and the conditional and marginal has been given, you can just multiply to get the joint distribution. Okay. And this is a basic example has been given for the same, I guess, the example with fx and fy represented here. Like for example, here this is a marginal distribution of x where x has been fixed 1. Okay, so if you have to calculate the marginal distribution of x where x is fixed 1, that means you need to fix x equals to 1 and do the summation over all the y, right? So what has been done? So after fixing the value of x equals to 1, we have just done the summation over all the y. So to get the value of 1 upon 6. And the summation of all the, when in the summation of the marginal distribution, you'll get the summation as 1. So if you do the summation of marginal distribution of x, you'll get to know that the summation is here also equals to 1, and for the marginal distribution of y also it's equals to 1. So to calculate the marginal distribution of y, what you will do, you just fix the value of y. Like for example, here the y value has been fixed to 0, and then do the summation over all the x. So after doing the summation over all the x, you got 6 upon 36, that is 1 upon 36. Okay, and if you will do the summation, you'll get to know that the marginal distribution of y also equals to 1. So this is the basic property of probability, like the summation of all the values of probability at each point should be equals to 1. And this is what happening here. Simply it has been calculated for the conditional distribution of x, and then, and if you need to know regarding, like not here, if you have to know regarding the independent random variable, whether it's a independent random variable or not, what you have to do, you have to calculate the marginal distribution at each and every point for x and y. Like for example, you have to show for whether this function, whether this random variable fxy is independent or not. What we need to do is to calculate the marginal distribution for the x and marginal distribution for y. Okay, whatever the matrix form you have got for each and every term. Like for example, here we got 4 cross 4 or 5 cross 5 cross 5, whatever we got. So each element to element, if you are doing the multiplication, if you are getting the correct joint distribution, like if that is matching with the joint distribution, then you can say this is independent. Otherwise, you can't. Even for one element, if this is not satisfying, you can't say, okay, this is a independent. So it should follow for each and every element. Then only you can say that this is an independent random variable. Okay, like for example, here it has been called this is the independent. And we'll discuss that in the next part, how to do the for the summation of x and y. Like for the summation, we have deal with there are methods, like in the continuous we'll be discussing. We have a convolution method also to deal with this. covariance and all, you already are aware of how to calculate the covariance. And if you're having the like, see, if you get the covariance equals to zero, then this is uncorrelated. Like, but the inverse is not true. That we have already learned, and that's true, I guess. And if this is the independent, then you got the expectation, even expectation of x, y, x into y. Okay, so these are all, I guess, the lectures of the recap videos. I guess this also is of recap only. And what is this? This all has been defined for the Bernoulli, binomial, Poisson, and geometrical random variable. This is a basic formula has been derived for how to calculate the expectation, how to calculate the variance for each of the cases, for the Bernoulli distribution, then for the binomial, then for the Poisson and geometrical one, random variable. So the formula will all, like, you can just go through that, but that's not important. So you're almost aware of that. So is the okay. So now we'll start with the 11th one. So the recap things has been discussed. Like, if there is anything you can ask, otherwise we move uh, in the 11th week, the continuous random variable. It will also start with the basic properties, the random variable. Then we'll go calculate expectation variance, then the multiple random variable. Then we'll just discuss some distribution like uniform, exponential, or normal. Okay. And this thing, the Markov, Chebyshev, this all will be discussed in the next week, like the maximum likelihood. All this stuff we will discuss in the next week. Okay. The 12th week that we'll discuss tomorrow. Here also the same stuff, whatever we were doing with the discrete, again we are doing with the continuous. The basic differences for the continuous, at some particular point you can't define any probability, right? And the same stuff we are discussing again, then union of, if you are, if this is in the form of union, if you are able to write in the form of addition, you can just write this is a disjoint set. So, okay. Are you here or like what is left? So for the continuous, what you need to do is just have to, while we were doing the summation in the discrete, in here you have to integrate basic integration. The same property, the summation of the integration. So doing the summation should equals to one. The property, the probability value should be always greater than equals to zero. All these steps. Again, the same basic properties for the discrete and again for the continuous. Okay. Anyone is having any issue regarding the, or should we move forward? Like, this is totally boring, I can understand, but because you've already read on the earlier uh, electives or subjects, right? So, do you want to solve some problem, or should I continue with it? This is totally boring. Like, nobody just, so for the what we did for the discrete will just again repeat for the continuous also. The same thing for the expectation. In the discrete, we are doing the summation. Here you need to integrate. The same basic formula, x multiplied with the whatever the density function we were using there, the mass function, here we will using the again the density function for the continuous, right? And after integrating you will get the expectation, right? The same basic thing, like for example for the uniform distribution, the basic, the density function is 1 upon b minus a. We have calculated the expectation and we got b plus a by 2. Similarly, we can do for the variance also the same properties, like same, the expectation of x square minus mu ka whole square. So, and the standard deviation is simply the square root of the variance of it. Okay, and the basic properties of, you can write for the expectation of x plus y every time expectation of x plus expectation of y, but you can't write for the variance x plus y as variance of x plus variance of y. If this is independent, then you can write, otherwise you can't write. For the expectation, you can write every time. Okay. So for the variance of x will be x square, a square into variance of x, and the variance of x is always greater than or equal to 0. Okay. Like for example, for the same basic example for the uniform distribution, we already have the density function 1 upon b minus a because it's defined from a to b. So we can directly get the density function as 1 upon b minus a because the area should be equals to 1. That's why we are taking the density as 1 upon b minus a. We can calculate the variance of x. What we need to calculate, we need to get the value of expectation of x square and then separate from the whatever the mean we have got. So expectation of x square we have calculated and then we have separated from the mean value and then we got the b minus a whole square upon 12 is the variance of a random variable, variance of x, where x is a random variable that has been defined from a to b in the uniform distribution. The same thing, the expectation, you need to calculate the conditional expectation, you need to calculate, you'll be having the, whenever you have to calculate the expectation of anything, you'll be having the density function, multiply with the x, do the integration from minus into the infinity or wherever it has been defined, you'll get the expected value. Okay, the basic like example has been talked there. Again, for the discrete, we talked about the multiple random variable. Again, here we are talking about the multiple random variable. So here again, the basic, the properties, everything will be same. The sum, the joint distribution of if you are integrating from minus infinity to infinity for all the x and y, you'll get the summation as 1. Okay, so and all the basic density should be greater than equals to 0 every time. Okay, and if you will tend to infinity, it should that the CDF will tend to 1, and if you will tend to minus infinity for x and y, it will tend to 0. So that's the basic, like the what is it? So the basic example has been discussed here. If you have been asked anything, if you have to calculate some constants and all, you need to just integrate it from minus infinity or wherever the domain or whatever the domain is there for that function, you need to integrate it and you'll get the value of the constant because the basic property you have to use. Similarly, the marginal distribution, the same thing you need to do if you to get to more regarding the marginal distribution of x, you need to integrate it over y. You have to just whatever you have been asked, like you have to calculate the marginal for x, you need to just fix the x and integrate it for all the y. If you have to calculate the marginal for y, you need to just fix the y and do the integration for the whole x. Okay. Similarly, same thing for the conditional will be you can calculate the joint distribution. How? You can just calculate the joint distribution as conditional multiplied with marginal distribution. So J equals to C Newton, just remember. So here there is a basic catch. Like if you have to calculate the x plus y and x plus has been defined as some random variable, this is a basic formula of the convolution operation. Okay, I'll just tell you the basic one example. Okay, so if you have been, if this is a uniform distribution, 0 to 1, so this will be 1 because 1 upon 1 minus 0, right? So the density would be 1 because the area should be equal to 1. So if this is x and if this is y, and if you need to calculate the convolution of x and y, x plus y, if you have to calculate, what will do? But generally, the basic convolution method, like I'll tell you directly, if the convolution, if you will do a convolution between x and y, what you'll get? You'll get a triangle, right? You'll get a triangle, and how will you calculate the values of like what should be the value of this peak point and what's the basic? I'll tell you the basic. What you can say? Concept that we generally, if somebody from the electronics would be here, we'll be able to know that. If
Midpoint.
there's an impulse that we are passing, and if this is the impulse that we are passing, and if you need to, if somebody was asking something,
Nothing. Sir.
okay. So if you have been a rectangular pulse in this form and you have rectangular pulse in this form, if you need to get an x plus y, what you can do with the convolution method, you can get the impulse of the final one. Impulse in the mean the distribution you can understand it. Okay. So what is this? The zero field. So what you will do is so if you are having a rectangular pulse, both the rectangular pulse and both the rectangular pulse or the distribution, whatever you're having, If the length and width is same for both the cases, we'll get a triangle. And if this is a different, we'll get a trapezium. How will you get that? I'll tell you. Like for example, what you can to get the direct value, what you can do, you have got the minimum value is this one, 0, 0. So you can add 0, 0, you'll get 0, 0 at 0. So what you can do, what is the minimum value of 0? And you can add this 1 or 0 here, you can add it 1. You'll get 1 only because the length is same. So what you'll get 0 plus 1 as 1. So this should be at the peak, the value would be 1. And if you'll add 1 plus 1, you'll get 2 here. So you'll be having a triangular pulse for x plus 5 or after doing the convolution. Okay. How did we get that? So that's the basic properties regarding that. So how will you calculate generally? So this is the method, right? So this is the
Yeah,
what
sir.
is the okay? This is the convolution operation that we do. Okay. So this is the function, like this is the x function and this is the y. So not function, but what is the density function and this is the density function for the y. So what we are doing? So for x, we are just keeping the same thing. For y, what we are doing just inverting the function because the x function here, what we are doing minus x we are doing. So inverting the function and we are adding some z here, right? So what we can do, like for example, if I'm having this function, this is the fx, right? And if this is fy, this was the fy, or what has been defined. Okay, yeah, this is the fy of x, right? And this is fx of x. So this for this function, what we are doing? So in the formula, what is been written? So this we are inverting. So after inverting the function, we'll get the function like this, right? This is the minus x, right? And after inverting, what we are doing here? After inverting, we are adding some variable sort of things, like for example, z has been added. So if we'll add z, so z can be anything, right? Z can be minus infinity also. So if we will add the infinity, so infinity means what? The box is there, right? So if this is some minus infinity minus x, right? This is some bigger value, right? And if we just start reducing the value of z, it will start coming here, right? And we already have this function here. So this I'll just draw both the function at one place. So this function I already have, right? So this function we already have, and this function I'm sliding here. So I'm just started sliding. So we are just varying the value of z. So I'm doing the same thing what has been written here because the value of z can vary from minus infinity to infinity. So we are just
Reducing the distance, right, sir?
what?
Reducing the distance. I mean,
Yeah, yeah. So we'll just move this box or the impulse or the distribution here. And so I'll start. So till now the function, because there is nothing common in that. So that's why every time it will be zero, right? The function value will be zero, right?
yeah,
Because
sir.
there is nothing common in between this function f of z minus x that we have converted and f of z, f of sorry x, right? So this is f of y of z minus x because we have converted this function, inverted this function, and after inverting, we have just added some variable z here. And after moving it, after some time, we'll start moving here. So now we'll start getting some common things, right? This is
Yeah,
the
sir.
common thing we are getting. Okay. So at what time it will become a fixed value? Like when we'll put when this box will come and overlap with this function, at that time we'll be having the peak value of. So what we are doing, we are just sliding this over this, and after sliding, start sliding, the value we are getting a zero. And for the first time, we will get something here, and the value will start increasing. The value will start increasing and will start increasing till
Overplacing.
this box will overlap with the. After overlapping, it will start moving again. So after overlapping, it will start again moving in the right side. Okay, if this box comes here, so it will start decreasing also. So it will start increasing, and at peak value, it will go to some peak, and then again it will start decreasing because the area, common area, will start decreasing. And what we are doing, we are just multiplying both the function and we are just doing the summation. Okay, so whatever the common area we are getting, we are just putting it here. So after some time, what we'll see, after some time, this box will come here. So after peak, it will come to some peak, and after that peak, it will come down, right? And after coming down, there is nothing common, and then again it will start decreasing and it will be zero. So till from minus infinity to here, it was zero, and from 2 to infinity, it again went to zero, right?
Yeah, sir.
So at this point, it got peak value. So this is pretty simple. If you'll get any time if you are having some rectangular pulse and both the rectangular pulse are same, so you'll get a triangular. That is for sure, right? And if I'll give you the uniform distribution only, but the pulse height, the pulse width is different, then what you'll get? Like for example, here I just increase the pulse width to 0 to 2 and the density becomes 1 upon 2. Now you'll get what? A triangular or trapezium. So again, the same thing we need to do. We need to just invert this and just start sliding over one function and we will start getting the values. So I'll just give you one trick regarding it. If whatever the rectangular pulse or whatever they have given, you can directly calculate that. So like for example, this is the pulse, this is the first pulse and this is the second pulse. And if you need to get the convolution of both the things, and if this is not equal, so we have in the lectures we have just discussed regarding the pulses or the distribution which are having the those are uniform, or you can say the width is same, but here the width is different. So what I told you to go through one method, 0 and 0 you can add. So 0, 0 is 0. This is the minimum value. Okay. Again, you can add 0 and 1. So 0 and 1 is what? 0 and 1 is some 1, right? And again, if you add 0, 1, it is 1, 1, 0, 0, 0, we got 0. So this 0 and this 1 we got. So 1, 0, 1, 1. 1, 1 we can add. So 1, 1, what we got? 2, right? And one more thing, the largest one and largest you got 3. So if you are having 3 points, so what? Will start getting the value will start increasing when the overlap will start. Okay, and then it becomes constant for some time, right? Because how did it become constant? Because if you are sliding this one, or like for example, this will become the inverted one, right? And if you are sliding over this box, so we'll start sliding over this box, it will come here, so it will start increasing. It will go, so it will overlap at that point, it will be maximum. So even if you are reducing this value, because the pulse width is more like larger than the pulse that over which we are sliding, right? So if we are sliding also, like for example, this is the pulse, so it will go like this, right? Because this the pulse width is more than this won't be like this. This will be like this because the density is lesser than that of the earlier one. So it will start sliding and it will go till the point, the maximum point. It will go till here. It will go like this, right? So it will start increasing because we are sliding. So I guess this is getting messed up, but I'll try to explain you again. So this was this is the example. This is the one impulse I'm having, or this one signal we are having. Okay. So what we have started? We have started doing sliding this over this. So again, we are doing this is my function. I started because this is the width of 2 and this is the width of 1. Okay, so I started sliding over this function over this impulse, and after some time I'll start having some common area. So now if I'm having some common, so earlier it was 0, there was nothing common, so the integration we were getting 0. So whatever we were getting some 0 value, because for one function we were able to get some value, but for the other function there was nothing. So anything multiplied with 0 was 0. So till this impulse reached here, we were getting 0. So till here it was 0. As that started having something common, so the value got started increasing, and one time we'll get to know this will be overlapping. There will be some area where there is nothing, but if we'll do the integration and taking the common area, so we'll get to know this is the common area you are getting. Okay, so this is the peak value, but that will not increase further, because if you are sliding more, so that is the only common area, because this is the, so I'll just try it, because this is the common area you are having, right? Even if you are sliding this from here to here, so the common area will be remaining this much only. So what you have to do is so the point at the time after sliding, this whole impulse, what the bigger impulse that we have inverted, so till the time it will go here, Okay, so till the time it will go here, the value will be remain like this, because we will having the common area, whatever we have started from here, the common area will be a only, whatever you are getting from the starting, because the common area was this one. Even you are sliding or not sliding from here to here, the common area was a only. If you start sliding further, what will happen? This box will get shifted rightward. If this box will get shifted rightward, now the common area is this one only, right? So if the common area is getting reduced, now the value will start reducing, and at the time when this area there is nothing common, again it will come to zero. Okay, so this the point should be this one only, 0 1 2. So not this one, this is wrong. So it will be like this at 2, and then after 2 it will start reducing, and then again it will become 0. So it will be a trapezoid, right? And this point you can calculate because the area should be equals to 1, whether it's x plus y or x or y. So did you get the point? How did you generally calculate the convolution? If you have not understand what, so the base method is to, if whatever the impulse you're having, like for example the x impulse you got like this, 0 to 3, and you got the impulse of y, 0 to 4. Okay, and you have been asked to calculate the impulse for x plus y. Okay, so you need to so after convolution, what you will get? Can somebody tell me? If you are doing the convolution of x and y, what you will get? Plot, at least can somebody tell me what is the plot? So the simple method is you just have to add the minimum. What is the minimum value? 0 you got, comma, 0 3 you got 3, 0 4 you got 4, and 4 3 you got 7. So this is a trapezium that will start from 0, it will go till 3, it will remain constant till 4, and then will start decreasing and will decrease till 7. So it started from 0, it will go at the peak value at 1, and then will remain constant till 4, and then will start decreasing. It will be 0 at 7. Can somebody say something? Is it clear or what? Like,
Yes, sir, it was clear. so this is the convolution. One more thing is the transform random variable. So does anybody understand this? How generally you do the transformation? We have already studied for the one random variable, like how generally you were able, like for example, if you have been given some sort of y, x has been defined, and you need to calculate the y equals to 4x. So the distribution for 4x, how generally you were able to calculate? Can somebody tell me? If you have to calculate distribution for y, how generally you were calculating? So g distribution of, so you need to write the distribution of fx, and then you need to multiply with dx upon dy. That you were doing the stats, right? If you are having only one single random variable. Here you are having two random variables, right? So how will you do that? So you have been given x and y, right? So fx, so the distribution for fx y has been given already. Okay, so distribution for fx y has been given. Some value has been given already. And you have been defined some transformation. So transformation also you have been given. Okay, transformation you have been given, like for example, u is equal to 1 by 2 x minus y, and v equals to y. So this is the transformation you have already got. Now you need to calculate the distribution of FUB. How will you do that with the help of xy? the same formula you're using, right? The same thing you have to use. So fxy, and then you need to just multiply with what you were earlier doing. You were multiplying with this one, right? So now you need to just multiply with the Jacobian. Okay, and how will you calculate the Jacobian function? So that Jacobian can be calculated. How will you calculate the Jacobian matrix first? So whatever the thing you have been given, like whatever the transformation you need to calculate, you need to write. So you need to get the inverse of this. Like you need to write the xy in the form of uv, right? So how will you write this? So if you see this y directly, you can write v, okay, and x, what you will write? X equals to 2u minus p. 2u minus b, you can directly write it x, or plus b, sorry, plus p, because it will go this side. So now you have the distribution x equals to 2u plus b and y equals to v. So the Jacobian is what? Jacobian directly simply you need to differentiate this function with respect to x and differentiate this function with respect to y. Right? So dx upon d, not with respect to x. So whatever the function you are having, this function you need to differentiate dx dv, or you can write this way. So there are 3-4 steps that I'll tell you again. So like for example, you have been given some joint distribution. Okay. So joint distribution has been given. Like for example, the joint distribution of x and y has been given. And the transformation also you have been given. Like for example, the transformation is u equals to half x minus y and v equals to y. Now you have been asked to calculate the distribution of FUV. So what you will do, the first step is, so this is a formula that you need to use every time. Okay. So what you will do, you will just inverse this. So first step is to write this x and y in the form of uv. Okay, so we did it. So we just showed y equals to v and x equals to uv plus v. The second step is to calculate the Jacobian. Okay, so calculate the Jacobian function first, and then you can put it here. You'll get the value, right? And the third step, the second will fix up, and the third step is to calculate the domain of u and v. So I'll give you one example. Maybe that will help you. Like for example, the density function of x, your joint density function has been given like 1 upon a square e to the power anything you can just write x plus y by a, where x and y is greater than equals to y. Okay. And now you have been given the transformation. What is the transformation? So you have been given the same transformation, that is I gave it x minus y and v equals to y. Right? Now you have been asked to calculate the joint distribution of uv. How will you do that? How will you do that? This you can write it like this, right? Fxy, and that you need to multiply with the Jacobian function, right? So the first step, what I told, the first step is what? We need to calculate going to write the xy in the form of, so whatever the transformation you have been given, just write this xy in the form of uv, right? So if you calculate, you will get y equals to what, v, and if you just put it here, you will get x equals to 2u plus v. Okay. So to get the value, we need to just calculate the Jacobian. How will you calculate the Jacobian? So now you need to calculate the Jacobian. So Jacobian was what? Del x upon del u. So if you see del x upon del u, you will get 2 here, right? And again del x upon del v was 1, right? And then del u, del y upon del u is 0. And del y upon del v is 1, right? So Jacobian function you already know, right? d by du, or you can write either way. You can write it here dy upon du also, and dx upon dv, and dy upon dv, or you can write dx upon dv here. So both are almost same. Okay. So and then you will be having the Jacobian function as 2, right? So what you can do, you just have to write it here 2 multiplied with whatever the joint distribution you are having. You can write here. Okay. And to get the, because you have to fix the first step you already did, you transform the x and y in the form of u and v, like, or, and the second step you just calculated the Jacobian function, and the third step is to know the domain of xy. So x is greater than xy is greater than 0. The same thing what you will do here. So you have the transformation. So when x is greater than 0, that means what? So we were having this one, right? So 2u plus v greater than 0, and y also greater than 0. So man means v is greater than 0, right? V greater than 0. So you got from here, you got v is greater than 0, or you can say from here you got v greater than minus v greater than minus of 2u. So this is the two domain you got. And if you need to write the distribution function, joint distribution of uv, what you can just write it here in spite of x and y. Whatever you have got the transformed value, this x and y, you can put it here, multiply the Jacobian, write the domain, you got the joint distribution of uv in the form of x. So the same thing what we have studied in stats we are doing just for the two variables. The same procedure we are doing here. Is this clear? Is this clear? Somebody can speak something, or everybody slept?
So it was clear, sir.
Okay. So this was the new thing, only the convolution and the transform random variable. Other than that, everything is almost same as what we have uh, studied, or what we have studied earlier. And the final lecture of the 11th video, just the sum distribution has been discussed, the uniform distribution or the normal distribution, I guess. So for the uniform, we already calculated the expectation and variance. Similarly, for the exponential also, it has been calculated. And for the normal also, the, I guess everything has been calculated. So these are all things you are repeating, I guess, twice or thrice, I don't know. But yeah, this is just a repetition of all the concepts that you have read earlier. Now, if you are having any doubts in the questions, any graded assignment, practice assignment questions, you can ask. Do you want to solve some problem? Can you start with solve with us for 11th week? Do you want to solve some problem? Do you want to solve some problems or what? Are you able to hear me?
Yes, let us go ahead.
Okay, so I'll start with that. So I don't know how many of you will solve the problem. You're already got bored of.
Yeah, afternoon 2 o'clock normally people will be dull. Immediately after lunch and it is
Lunch.
napping.
Yeah.
Okay. So these are some basic problems. We'll just go through that. They're all simple. So I just want to ask, if you have any issue, like you have to submit that, I guess this Saturday also. I'll just go through the graded. So, so in the graded also, if you're having any issue, you can just not solve, but how many of you have submitted that? So all the problems are very basic. So, like again, here you have to just integrate it from 1 to 6 and you'll get the value of A. Okay. And then after getting the value of A, you need to just integrate it from 2 to 5, right? So there is nothing new in this. Here again, you need to just integrate it from 0 to 4. Like for 0 to 2, you have a different density function. From 2 to 4, you have different density function. You need just to integrate and you get the value of A and then integrate it from 1 to 3 to get the probability function value. Similarly, same thing again. Here you have to calculate the expectation. So the expectation, you already have the formula. So here we have, this is the simple normal distribution from 80 to 100, and then you need to calculate the mean and variance of the length. So here there is no bad outside this. Okay, so this is simply a random uniform distribution from 80 to 100, and the mean and variance you need to calculate. So the mean and variance formula you already know, a plus b upon 2 and then b minus a whole square upon 12. That is the variance, and you can calculate a plus b, right?
So
Similarly,
in our end term, will this be the major, will this have the major weightage?
you'll have a weightage from a good weightage from these sizes 8 or 9 to 12.
Okay. Okay.
But you'll get the problems from all the weeks,
Okay. Okay.
like some 1 or 2 questions. But from the last 4
Sir, your
lectures,
voice was breaking, sir.
is it clear now? Hello. Is it clear now?
Yeah, it's clear, sir.
It's clear, right? Okay. So what is that? No. This problem also is not that difficult. You can just, it will
No,
not
no, sir.
take
What will be the major portion, sir?
what?
I mean, for end term, which will be the major portion of the weeks?
So the major portions, like We'll be having a good weightage from week 9, 10, 11, 12,
Okay. Okay, sir.
but we'll be having weightage from 1 to 8 also. So each week, like from like class, you can expect like from last 4, 5 weeks, we'll be having 2 questions or from each week, and then you can expect some 1 question or 1.5. So what you can say, like from each from starting 1 to 8 week, we'll be having 1 question from each week. Not it's not like fixed, but I'm just giving you a brief idea.
Yeah,
This
so normally so, for Entom it will be like, sir, last 3 weeks or 4 weeks will be covering of 60% and 1 to 420, 4 to 820 like that. Before like that, it was there, sir, for foundational level or like
yeah.
quizzes also
So
for
yeah, here
last.
also it will
Yeah.
be almost same, but you'll be having like 50%, or you can say 40 to 45% weightage from last 4 weeks itself. And from the first 8 week, you'll be having from the starting 4 week, you'll be having lesser weightage like 20-25%, and then from fifth to week, you'll be having like 25 to 30% weightage, and the rest 40 to 45 to 50% will be from last 4 weeks. It is
Yeah, okay, sir.
good, right? You have like 11th week, you already have read. If you get some more questions from these weeks, you will be able, you'll be in the place to solve the problem, right? And one more thing, so I'm asking you twice or thrice. Is there any problem in the marks that you have got for the question? Like somebody is just asking on the discourse itself. Any of
I
you
mean,
have
in
any
which part, sir? Are any questions or any options? I mean,
like
calculation
some
error or question?
some students are saying that the marks got reduced today morning. I don't know how. So okay, I don't think so. This is the issue for some 1, 2 guy only. That I've already told you from the starting. Like we have given the 8 marks for those problems that would have taken time, that would have eaten your time in the exam. So we have just given the 8 marks for those questions, and we have removed 1 question that was a pretty simple one, that volume definiteness that would not have taken much time. So we have removed that, and we have given 8 marks to everyone for that SVD problem and that eigenvector problem, and everything else was fine. But yeah, we are really sorry for that. Like I only prepared the question, but I don't know how it reviewed by the professor also, it reviewed by our colleague also, but nobody has pointed this out. So this happened for the first time. I don't think so it will repeat again. So yeah. So here also again you need to just integrate it from 0 to 2 and 1 to 3, and you'll get the value of C, and then you can just calculate the value of C. Again you need to integrate it. So it's a basic, all the questions here are just you to integrate it and you'll get the value. Some are basic theoretical questions also. So yeah, it is doable in half 1 hour. It's 25, 26 questions you'll be able to solve. Okay, so you can just solve some problems. These are all basics only, because we are just recapping all the concepts of the probability. We are not going in some difficult problem that we have already did in stats 2. So will not give you any problem that is a bit difficult. So all the concepts are basics and conceptual. This is a problem, same problem I guess. Only the data are same. So the graded assignment, if you are able to solve it here, you can solve it there like that also. You just have to integrate it, get the value. Just tell me the value of A, and then you can integrate from 3 to 5. Are you solving? Should I wait for some time? Are you guys solving or what? Should I go next? Can somebody reply?
Yes, sir. Solving, sir. 1 minute.
Okay. Okay.
So the way to get A is integrated from 1 to 6 and equated to 1, right?
Yeah, yeah. You can just integrate it from 1 to 6. You'll get the equated to 1. You'll get the value of A.
I'm getting something weird actually.
What is that value?
My integration is 20 plus 2 by 3 minus 7 by 2.
The value should be around 3 upon
20
1,
point something?
125.
Yeah, so 1 by 20 around, right? So that's correct, right?
1
It's
by
about
20.
1
Yeah,
by
yeah.
20.
And then to calculate the probability, you can just integrate from 2
Yeah,
to 5.
integrating. Yeah.
The base is simple. So again, the same sort of problem. So the amount of time a student takes to solve the problem uniformly distributed with an average of 12 minutes. So that means A plus B upon 2 would be 12. And the variance formula you already know, B minus A ka whole square upon 12. That is equals to 1 upon 13. So that will give you A plus A and B. And then you can calculate the value of probability 10 to 12.5. Did you get the point? Like, what did I told?
Yes, sir. What about the upper limit? 12 is 12 minus. Okay, okay, got it, sir.
You can just take some random value and then we'll be having two variable, two equation. You can solve those two equations to get the upper and lower limit.
When we don't know the range, so how can we do it? I'm not actually able to solve this.
Which range you are talking about?
This is uniformly distributed, right?
Yeah, so you can take from A to B, right?
A to Z.
A to B, some random alpha to beta, okay?
Okay.
And if you are defining alpha to beta, some uniform distribution is defined from alpha to beta. That means the density function would be 1 upon beta minus alpha, right? Upper limit minus lower limit.
Yeah. Yeah.
So that the area should be equals to 1, right? Okay. So if you're having the average time is 12 minutes, that means what? The expected value is 12 minutes. That means the expectation of uniform distribution is what? A plus B by 2. Upper
plus B by 2.
limit plus lower limit upon 2. So you'll
Correct.
be having A plus B upon 2 equals to 24. That means A plus B equals to 24. A plus B upon 2 equals to 12. A plus B is 24.
Yeah, got it.
Okay. And the variance is what? 1 upon 3. So the variance is what? For the uniform distribution, you have the variance as b minus a ka whole square upon 12 equals to 1 upon 3. So you'll be having a minus b ka whole square equals to 4. A minus b ka whole square equals to 4 means a minus b equals to plus minus 2. Right?
A minus B whole square. Sorry?
A minus b ka whole square upon 12.
Upon 12.
Yeah.
Yeah. Got it.
So this is the value. So this is the equation. A plus b ka whole a plus b upon 2 equals to 12, then b plus a is 24, and then the variance you can calculate. Then b minus a, it can be plus minus 2, either you can take, and then you can solve this two equation to get b equals to 13, and one will be, so if you are taking b equals to 13, that means a will be equals to 11, right? And then you can calculate the area from 10 to 12.5 to get the value of the probability value. This is clear? Or you can calculate the area from 10 to 12.5 because you have the width and length of the rectangle. So you can calculate the area also. Is it clear?
Yes, sir, got it.
Oh. This is the next question. So answer is also given there. But the exponential problem, I guess. Yeah. So this is a number of days a traveler purchased their airline ticket is exponentially distributed with average amount of time equals to 28 days. If there is 80% chance that the traveler will purchase the tickets fewer than D days in advance, then what is the value of D? Right? Your answer here is. So it's the exponential distribution, right? The exponential distribution you can write there. Okay.
Yeah, sir. I don't actually remember the formula, so.
Okay. So this is like okay. So what has been given? The exponential is generally how generally we write for the probability x.
Got it.
Yeah. So you can directly write. This is the basic formula for the exponential distribution. Probability x less than equals to d is directly you can write 1 minus e to the power lambda d. Lambda is the mean value. The mean value was given there. And mean for the exponential distribution is 1 upon lambda, and the variance is 1 upon lambda square. So variance is not used there. So expectation lambda you can calculate it from there. Lambda you input there, and then you solve. You can take the log also to calculate the value of that d. And get the d is around 45 I guess. 18 into log 2 ln 2. You'll get around 45 I guess. So this type of problem you'll get in the exam also because it's not a heavy stats course, so not much difficult problem. So this is the next problem. If the mean and variance of the exponential distribution are 1 upon lambda and 1 upon lambda square, that I told you, then which of the condition for which condition the variance will be greater than the mean? This is pretty not that difficult. So in which condition 1 upon lambda square will be greater than 1 upon lambda? If lambda is greater than 1, like for example, just take some random stuff and then you can imagine.
How can lambda be greater than 1 actually? Lambda is always less than 1.
The B, it will be B.
Yeah, it will be B. So lambda
Yeah.
can be greater than 1, right?
Yeah, let's say it is 0.5. Then the
I'm saying
be
if
0.25.
So
right.
for this condition, lambda should be from 0 to 1 because if you need to get something 1 upon lambda square as a getter, the lambda should be less so that the squared form will go in the numerator and will increase the value. Yeah. Is there any doubts in this problem? This is the so 1 upon lambda square should be greater than lambda, and then lambda should be considered. Okay. So this is the same type of problem. Again, you have the exponential distribution function with mean equals to 18 months, and then there are 60% chance the light bulb will last for at most 6 months. Then what is the value? The same things you have to use. So the exponential distribution, the probability you already know. So everything is the same step. Again, you will get the value as 18 LM 2.5. If you want to try it, you can try it. So this, I guess, is there in the graded assignment also. Maybe the value will be changed, but the same different type of problems as there in the graded also. Okay. This is how it has been solved. So again, the probability x less than t is what? 1 minus e to the power lambda, e to the power minus lambda t. And lambda you already have as a 1 upon 18 that you can put it here to get the value as t equals to 18 lambda 2.5. So here, let x be a uniformly distributed function from a to b with exponentially of expectation of x is 5 and the expectation of x square equals to 28. Then what is the value of b minus a? Can somebody calculate this? So answer has been given here, but can somebody calculate it and tell me the procedure? Is anyone trying this? Or should I move forward? Should I show you the solution?
The thing is, it will be like a plus b by 2 is equal to 5 and b minus a bracket square divided by 12 equal to 28.
No, not this is not variance, right? The expectation of x square. This is like a square plus b square minus ab upon 3. This you need to calculate the expectation of x square. You have to calculate for uniformly distributed function because this is not the variance, right? Or you can calculate like this. You have already you know the variance. Variance is b minus a ka whole square upon 3. Okay. Minus you generally do the mean. Mean you can subtract it. Like if you are subtracting mean from here, you will get the variance, right? Mean ka whole square if you are subtracting from this value. So variance is what? Expectation of x square minus of mean ka whole square. So if you are subtracting 5 ka square from this value, you will get the variance, right? From there you can calculate. So this is the function. So variance can be calculated. This square, this expectation of x square minus mean ka whole square. Mean is given as 5, so mean you can subtract the square of this. You'll get 3. And then you have the formula b minus a pi whole square upon 12 equals to what are you getting? 3 multiplied with 12, so 36. Again, b minus a is plus minus 6, then you can calculate. So you have to calculate the difference only. So the difference is 6.
Yep.
It can be minus 6 also. The same basic formula. This the x is a random variable with expected value of 5 and the variance as 1. Then the expectation of x square. So again, you can use the same formula. The expectation of x square is what? The variance plus the mean ka whole square, right? The same thing you can use here also, correct? If you have to calculate the expectation of the variance, you already have. So variance is what? Expectation of x square minus the mean ka whole square. If you have to calculate the expectation of x square, you can directly write as variance of x plus mean ka whole square. So variance of x plus mean ka whole square you can do to get the value of this one. So you can do it
Yeah.
directly. Here you just have to integrate it from 0 to 2. The multiple integration is there. So you need to integrate it first, taking one as constant, one as variable. To integrate from 0 to 2 and then integrate from 1 to 3. You'll get the and equate it to 1 because the basic properties of the probability is that the summation of all the values are all the points should be equals to 1. So after integrating, you will get equated to 1 to get the value of p. Can somebody calculate the value of p here? It's pretty simple one. Does anybody calculate this? Then go to the next problem. Suppose that the random variable x is uniformly distributed between 0 to 1. Then calculate the probability such that x plus 10 upon x greater than equals to 7. How will you do that? Can somebody tell me the procedure? Can think for 30 seconds and then tell me the procedure. So what you can do it here, you can just solve this quadratic equation, x plus 10 upon x greater than equals to 7. If while solving the quadratic equation, you will get some value of x, where it is the curve. Like if you are solving this equation, x square plus 10x minus 7, so you'll get some 2 root, okay? And if you'll get 2 root, so you'll get some interval where the for this x will be satisfied. For those x, you need to calculate the probability. So you'll be able to calculate. So while solving the quadratic equation, you'll get the some limit, some boundary values of x, and for those boundary values of x, you need to calculate the probability in this uniform distribution. After calculating, you'll see that you'll get 0.7 as the probability value. Can somebody solve this? I don't think so. Anybody is interested? Okay. So these are some basic problems that was related to 11th week. So if you are having any issue, you can ask me now. Like if you so all the concepts are almost similar. Only two new concepts has been added: the convolution theorem and the transformation of transformation. Also, you already have read for one variable, but here we are transforming into different variable, right? So that's the only two things that we have discussed there. Okay. If you want some problems on the transformation, also we will provide you. to solve some problems. So, but those are pretty, just you need to know how to calculate the Jacobian matrix. That's it. Other than that, I don't think so there is anything new. You can just submit it there. You can just go through the 12th week lecture also. We have the session tomorrow also for the 12th week, right?
So can you suggest now how to prepare for week 9 and 10, weeks 9 and 10?
Week 9 and
And 10.
10. So the lectures are good, right? You can just practice those problems graded and practice only. Solve with us you have attended, right? For week 9 and 10. Week 9 is
sir.
what? Week 9 is like you have to solve the objective function with some constraint, right? Week 9, yeah. Week 8 was without any constant. Week 10 is with constant. And week 8 was without constant. Week 9 with constant. And week 10 is like KKT conditions and all those things. Right. So you are having issue in week 10, right?
Yes, sir.
So what you can do, you can just go through the lectures again. And maybe we'll be having the sessions for those revision sessions next Monday, I guess, next week, not next Monday. So till that time, you can just uh, put your doubts and then you can ask in the revision session, or you can just put it on the Discord, or can ask anytime. Say, many of the people from you will generally message me, so I generally reply them. So you can just ask it there itself. If you're having, so only the lectures is more than sufficient. Right? In week 8, 9, 10, I can say. Like, if you just go through once again, I don't think so there will be any issue. And you're facing the doubt, like further, if you are facing any issue, you can just contact Ram or me for that. Is it fine?
Yeah. Okay. So if I solve the graded assignments and practice assignments, will it be enough?
Yeah, it's enough.
Actually, I missed the deadline also.
Okay.
Yeah.
For 10th week.
Yeah. 10th week. It was 17th, right?
Yeah. So,
I just started with that convex functions and all, and properties of convex functions and all.
Okay, then what? So, for how many weeks you have to submit to get the 8 week, right?
Yeah, I'm already eligible for that.
Okay.
But I couldn't submit for this
Yeah,
week
so but
10.
now you have the time, right? Because the final exam is on 7th, so you have much time.
Yes, sir.
15 days. So you can just start it from 11th week is nothing new in this. So you can, if you want to skip to watch the lecture, you can skip that also. Okay. You can just go and solve the problem. I don't think so there will be any issue in solving the problem. You can just solve the problem. For 12th week, you can, there are only 4 lectures for the 12th week. So, and for the, out of that 4, 1 or 2 is like you already know regarding the Chebyshev and all. Markov. So you already know regarding the 2 weeks. So only 2 weeks are new for you in the 12th week also. So now you are left with only 9, 10 weeks. So those things you can just go and repeat once again, right? So 11th week is having so much of lectures, but those lectures are like already you have learned somewhere in stats 1 and 2. So you can just skip it also. Is it fine?
Yes, sir.
Okay, so the 11th week we are like, there's nothing much. If you're having doubt, you can ask. You can ask it on the Discourse also. You can mail me, message me, whatever you want to do, you can do. Just submit that today itself or tomorrow. So 24 is the deadline, so submit it before today itself so that you can watch the lecture for the 12th week and then you can submit for the 12th also. The 12th week is also not that difficult, only 1-2 concepts are there. So we'll discuss it tomorrow. Okay. So So if you're having doubt, you can ask. Otherwise, I'll close this session.
So this solved with us PDF that you showed, that is uploaded somewhere.
Yeah, I'll upload it. I'll upload that. I'll make sure to upload. So for the rest of the week also, for till 10th week, it has been uploaded, right? I'll upload
Solved
it
with
for
us. I don't know where the folder is for solved with us. That is not listed in the list of folders.
Okay. Okay. So I'll just ask the team to upload the whole solve with us from week 1 to 11.
Okay.
Okay.
And one more small conceptual doubt in week 11, lecture 1.
Okay. What is that?
There is that first or second slide where 0, 1 to the power of omega is given. No?
Yes, 0, 1 is just a way to represent. And 0, 1, what is that? Like 0 is to, if you are having some, this is the general representation of power set. Okay. Power set means power set you already know, right? So if you are having some sample, like for example, this head and tail is there. So two outcomes is there. So the power set will be having phi or head or tail or head tail. So this the 0, 1 means either you are taking head, either you are taking tail. So this is just a way 0, 1 means you are taking what you are taking out of that.
So 0, 1 denotes that only two possibilities are there, or
No,
event
like
occurs and not occurs, or
yeah, occurring, yeah. So like for example, I took phi in the power set. Okay, so phi means what? I didn't took the head also, I didn't took the tail also. It's just a way, like because if you have to count the number, whole number, this is how you generally write. Like you are writing phi, that means you are not taking mean 0 for head also, 0 is for tail also. If you are just having a same space, like set where only head is there, so that means for head you are taking 1 and for tail you are not taking anything. And if you are taking head, tail both, so you are for both you are taking 1. This nothing special in that. This is just a way some books generally present the power set in this form. So 0, 1 to the power omega. Okay, nothing special about that. Nothing important also. This is the way
okay.
generally we write.
Thank you, sir.
Okay. Okay. Anything else? Okay. Thank you everyone for joining the session. I'll just ask to close. Thank you. Thanks, Peter. Thank you everyone. Thanks, Anwar. Thanks, Raj. And thanks everyone.